Hello, guys. Welcome back to Maison African Motives. Still on mathematics N4, that is working on differential calculus, that is on the derivatives. So we are going to focus actually on the limits, that is the limits of the indeterminate forms, which is the first part that you actually need to understand in your differential calculus, how to apply the limits. That is, we're referring to a condition. Maybe you substitute whatever limit that you're given, then we obtain forms of 0 over 0 like this, or we are obtaining infinity over infinity, or maybe we are obtaining maybe infinity minus infinity like this. Or it's a condition, maybe you're multiplying 0 times infinity like this. So these are the conditions that you actually can end up with in our expressions. Not applying the L hospital rule. We are not going to focus on that one. That one is for our mathematics N5. As we're just focusing on the basic approach, which is the one that I'm going to show you. So we have got a condition. When we are referring to limits, what are we actually referring to? Let's just take an example of having a limit like this, just a normal limit of a certain function. It can be a function of x or y or whatever function that you're given. For example, let's just say x squared. And we are given a condition of x being limited to 0 like this. What it simply means is that where there is an x, we simply need to substitute a 0. So if we are to substitute a 0 in this case, in here, we are going to obtain 0 squared, which is equal to 0. In this case, let's say we change our value, in this case of x, to approximate 2 to 2 in this case. Our x is approximating 2 to 2. That means we are going to substitute just like the previous part. In place of x, you're going to substitute 2, that is 2 squared, which is 2 to the exponent of 2, which is going to be a 4. So these limits, they are just direct limits that we are having. But you can be given fractional limits. So before we deal on those fractional limits, what we just need is that at least let us understand some of the things that we need to know on our limits, like the rules or the laws. Just like exponents, logarithms, we have some rules and laws that we need to follow. So it follows that on our limits, let's say we have got a limit of a constant, which is referred to as k, and we are saying x is approximating to a certain number. This is in terms of k, not in terms of x. So it means everything that we have is going to remain as it is, as a k, because we are saying x is approximating to, but we do not have x in this case. We have got a k. So meaning to say the limit is not affecting anything. All right. Then the second part, if we are given a condition of a limit of, let's just say k over x to the exponent of n, and this x is approximating to 0. So you've got a condition whereby x is being raised to any exponent that you can think of, any exponent, whether is to the exponent of 100, is to the exponent of 2, whatever exponent that you can think of here, that is what we are saying. This is going to approximate to infinity. So this one is going to approximate to infinity. To say that it's actually something that these are endless values that you're talking about. So that is why we end up with conditions of any number over 0 like this. We are saying this is going to approximate to infinity, any number that is over 0. So this is a limit that we are saying, we are dealing with infinity values that we are having. All right, which is the same thing or the opposite now, to say if this limit now of k over x to the exponent of n. So we've got our limit here of k over x to the exponent of n. And this time our x is approximating to infinity, like this part. This one is approximating to infinity. It means we are going to obtain a 0, just opposite of what we have. If this is a 0, then it's infinite. If this is infinite, then this gives us a 0. So it means any number that we are going to have, maybe is 3, over infinity like this, we are saying this is going to give us a 0 at the end. It approximates to a 0. So these are some of the limits that we just need to understand, especially in our syllabus for mathematics. And for this part is very, very important. We shall talk about others as we move on. All right, I was saying, given a condition whereby we have got limits that we are working with on division, and we are working maybe division or its multiplication. So like I said, here we are going to add others. Okay, let's have a condition whereby we are given limits. All right, limits by factorizing or by factorization or division. Limits by factorizing or division. So we can have a condition where we can work with limits under factorization or under division. This is a condition whereby we are having fractions, and these are limited to a condition whereby we have infinity over infinity like this, or we have got 0 over 0 like this. That is where we can think about this part of factorizing. Since it's like I said before, that we do not have the L hospitals rule in our syllabus, so we are not going to focus on that one. So let's have a condition to say just a basic question. I will explain. Let's say we are given to determine the limit. In this case, determine the limit. All right, so we are given to determine the limit of. So let us just have our questions here. The first one, we can be given a limit of x squared minus 4 like this over x minus 2, as x here is approximating to 2. So I want you to see what is going to happen here. The first thing that you do is you substitute the values that you're given. X is approximating to 2. So meaning to say here, we're going to put 2 in place of x. So as you can see, if you substitute on your calculator in place of x here, you put 2, that will be 2 squared minus 4, which is 0. Here it's 2 minus 2, which is a 0. We are obtaining 0 over 0 like this, which is a condition that we have on this part. So if you were using L hospitals rule, you are going to find the derivatives of the numerator and the denominator, but we do not have that in our syllabus. So the thing that you're supposed to think is to factorize or to divide by the highest exponent that we have in the expression that we are given. So here we can see that we can factorize the numerator. So here by factorization, we can factorize our numerator here by factorization. So let us try to factorize our numerator. Given x squared minus 4, we know this is taken from a difference of two squares, where we have got a condition of a squared minus b squared, which we say this is given, or this is going to give us a minus b into a plus b. So meaning to say, if we can apply the difference of two squares here, this can be written as x squared minus 2 squared. 4 is same as 2 squared. So meaning to say we have got x minus 2 and x plus 2. The numbers that is being raised to the power of 2. So we've got x minus 2 and x plus 2. So this is what you're going to obtain in this case after factorizing this part here. So we are going to say at the end, we are going to obtain a limit of, so this will be equal to the limit of x squared minus 4, which we said we are going to obtain the difference of two squares, where we've got x minus 2 into x plus 2, everything over x minus 2. So remember, we are approximating our x to 2. So this is what you're going to have at the end. So now, if we are to check here, by after factorizing, we can see that there are some brackets which are the same, the x minus 2 and the x minus 2. So these two can cancel, meaning to say at the end, we are going to remain with x plus 2. So we are going to remain with this part of x plus 2. So that is, in this case, we are going to remain with the limit as x is approximating to 2, and we are just remaining here with x plus 2. We do not have anything left, but only this expression. So we can substitute in place of x. If x is approximating to 2, that means we are going to obtain 2 plus 2, which is equivalent to 4. So at the end, everything here is going to give us a 4. So this is how we can actually play around with our limits. What is important is that understand the typical question that you're given, how to simplify that question, and also following the laws that we have listed before. All right, so I want something that is going to add up to these limits that we listed here, the limit of a k and the limit of this part of it. So let us just have another question again, still on determining the limit. So let us just have another question. Let us just have this as our B. So let's say we are given a condition this time, limit as x is approximating to infinity. X is approximating to infinity in this case. And we'll be given 2x squared minus 8 everything over x squared plus 2 like this. All right. So if x is approximating to infinity in this case, you'll see that if we are to put infinity here, this is not going to affect anything. This is going to be just infinite. And it's infinite minus 8. It's like we are subtracting nothing. So 8 is a smaller number that we can talk about. So meaning to say we are just going to remain with infinite in this case on top. So this is going to be infinity over. The same here, infinity squared, meaning to say we are actually increasing it. That means it's going to remain as infinite. And we add a 2, meaning to say we are simply adding nothing to infinity. So that one is going to remain as infinity over infinity. So what are we going to think about division? If we've got a fraction in this case, think of factorization. If you factorize in this case, let us try and see. I want you to see what is going to happen. If you were to factorize here, we are going to think about the numerator. That's why we've got a negative. We can think of the difference of two squares, factor out the 2, which is common. We are going to obtain 2 into x squared minus 8 divided by 2, which is negative 4. We've got a difference of two squares, just like the previous part. We've got two brackets, x minus 2 and x plus 2. But as you can see, these are not even common to x squared plus 2. So it means these cannot cancel. This is x plus 2. This is x squared plus 2. So these brackets are a waste of time. We are not going to, they are not going to help us at all because we can't cancel any bracket with x squared plus 2. But if it was x plus 2, then we could cancel x plus 2 and x plus 2, which means it was going to work. But because it's x squared plus 2, we are limited now. So meaning to say our factorization this time does not help us any. So we are going to think of dividing. So what do you do? What are you going to do? You divide by the highest exponent, the term with the highest exponent. So you divide by the term. Okay, so let us just say here, divide each term. Divide each term by the term with the highest exponent, but by the term. Okay, let's just say x, which is our term. Okay, no problem. You understand, by the term with the highest exponent, by the term with the highest exponent. So this is the highest exponent, which is the highest power in this case. All right, so that means we are going to check on our question. We've got 2 and we've got 2 in this case. These are the exponents that you're given and they're just the same. So meaning to say we're just going to use x squared because it's the same. So if it was maybe 3, we're going to divide with x to the exponent of 3, but this is 2. So we are just going to use that 2. So why dividing? Okay, no problem. Let me write this part so that you understand why are we actually dividing. So you're going to have each term is going to be divided by x squared. That is the one that is good. It was is the same exponent here. So we are going to divide each and every term. 2x squared divide by x squared. The same thing on minus 8. We are going to have minus 8 over x squared. Each and every term in the denominator again, the x squared is going to be divided to x squared. The plus 2 also is going to be divided with x squared, the one that we said it has got the highest exponent. So we've divided by x squared, each and every term. This part can even cancel. This part can even cancel. We remain with a 1. Here we remain with a 2. All right, so like I said, I'm going to explain what is the purpose of actually dividing. Why are we dividing? Because someone might wonder to say, why? What is the purpose of this? Okay, let us see what is going to happen. Here we are going to remain with 2 minus 8 over x squared. So this is 8 over x squared, everything over 1 plus 2 over x squared. So this is going to be 2 here over x squared. All right, so this is what you're going to remain with at the end. Now let us check what from this part here, what I was saying. If we are limiting an infinity, x approaching to infinity like this, of k over x to the exponent of n, we are going to obtain a 0 in this case. And this is our k, 8 over x squared. Remember I said any represents any exponent. It can be 2, it can be 100, it can be any exponent that you're given. So it means the moment we substitute infinity here, it's going to be infinity squared. Whatever that you're going to obtain, it is a 0 because it's a constant over x to the exponent of n, and x is approximating to infinity. So this is going to give us the same thing, 2 over x squared. This one is going to give us a 0 also because we are having x, k over x to the exponent of n. So that is the advantage of knowing or understanding these rules or laws that you're going to have on our limits. All right. So with this part, we understand that we are going to have our answer as we have substituted our infinity. So in this case, this one we have already substituted. So we are going to remain in this case with 2 minus, like I said, if we substitute here, this is going to give us a 0. It approximates to a 0. Everything over 1 plus 2 over x squared, again, it gives us a 0. So it's going to be 1 plus 0 like this. So that means at the end, we are going to have 2 minus 0 over 1 plus 0, which is going to give us a 2 in this case. That's 2 over 1, which is going to give us a 2. So this is how you play around with the limit. It's not like you know what is happening there. So try whatever that you think is applicable. The first thing that you can try is to factorize, like what we saw here. We tried to factorize, but we saw that the factorization was not working because if you try to divide, it is not canceling with this part of our denominator, which is x squared plus 2. So what you can do now is to divide each term by the term with the highest exponent. All right, I just hope we shall have another question similar to this one so that we can properly understand. So together, it must be with these laws that you are given here, that k over x to the exponent of n limited to x approaching to infinity is going to give us a 0. But having k over exponent, x to the exponent of n, when x is approximating to 0, this is going to give us an infinite. So these are some of the things that you need to take into consideration. All right, so let us check another question. Again, I'm just going to try to have it. All right, so let us see here. Let us see what we have in this case. Let us just see this part of factorization, the longer way of factorization in this case. Then we shall see the other part. We've got a time that we can work on. All right. So you've got the limit in this case of x squared. I want something similar to the last question that we just did. X cubed plus 1 in this case. And we are given x approximating to infinity. All right, so this is what we have in this case. So if you check, this is a similar question with the previous one, where we can see that even no matter how you try to factorize, here we are limited. So that means we are not going to do anything about factorization in this case. Look at our numerator, it's x squared. So there's nothing that we can do with x squared. So the only thing that we can think about is to divide each and every term by the term with the highest exponents. We are back on this condition here. The term must have the highest exponent. So you check on your terms here, which one has got the highest exponent. If we check here, we've got x to the exponent of 2, and we've got x to the exponent of 3. So 3 is the highest exponent that we are going to focus with. So we are going to divide each term by x cubed. So this is what you're going to have at the end. So we are going to have the limit as x is approximating to infinity of each term. So x squared here is going to be divided with x cubed, the one with the highest exponent. So it's over x cubed. All right, everything here we are going to have everything affected. That is x cubed over x cubed. Each and every term plus 1 over x cubed. Each and every term is being affected. So we can cancel here x cubed. All right, so let us just say there are 2 here. So there are 2. So into these ones, which are 3, we are going to remain with 1x. Remember, there are 2 x's here, so you're going to remain with 1x. So this is going to be 1 over x. Here is the same, x cubed and x cubed cancels. You remain with a 1. Here you can't divide because this is a 1, so there's nothing that you can do. So at the end, we are going to see that we are going to be limited to x approximating to infinity of, from the numerator part on top here, we got 1 over x like this. So this is a fraction. 1 over x is a single term that we just have here. Everything over in the denominator here, we obtained a 1, And this part we obtained plus 1 over x cubed. So this is what we got in this case. All right. So I want you to understand that once you are at this stage after dividing by the term that has got the highest exponent, therefore think of what I was saying from the laws that we have, that if we are limiting our x, all right, so let me just rewrite it here aside. If we are limiting our x to infinity in this case, and we've got k over x to the exponent of n, this is going to give us a 0. As long as x to the exponent of it can be to the exponent of 1, it can be to the exponent of 7, as long it's a fraction, k over that, like this part, 1 over x. So the moment we substitute infinite on 1 over x, just like this part, this one is going to give us a 0. The same thing here, we've got 1 over x to the exponent of 3. This one also is going to give us a 0. So at the end, we are going to remain with, we have substituted from the numerator on 1 over x here. We obtain the limit as x approximate to infinity. We say that's a 0. So this one is going to give us a 0 over 1 plus a 0 in this case. So as we know, guys, 0 over any number, like 0 over 1, is just a 0, okay? This one does not affect. 0 on top does not affect. It affects when it is in the denominator. So meaning to say, our answer is going to be a 0 in this case. 0 affects when it is in the denominator like this, 1 over 0. That is the one that approximates to infinity in this one. That is the condition that we say it approximates to infinity. Our denominator when it is a 0, not the numerator. The numerator has got no effect, like this part, 0 over 1. This one is the one that gives us, even on your calculator, you can simplify this and you see that it gives you a 0. But if you simplify 1 over 0 on your calculator, it will give you maths error to show that is not exact. That is why we are saying it's infinity. All right, so that is the application that we can have on our division concept. You divide by the term that has got the highest exponent. But like I said, some of the questions are limited to factorization. Just like for an example, this part where we have got the limit of x cubed minus 8 everything over x minus 2. Okay, this is a very special type of equation that we have. So in this case, let us try first to substitute our limits as x is approximating to 2. This is going to be 2 cubed minus 8, which is going to give us 0. 2 minus 2 in this case, which is going to give us a 0. That's 0 over 0. So meaning to say we're supposed to think of dividing by the term with the highest exponent, but let us try to factorize, because this can be factorized from which concept? That is the question. How can we factorize x cubed minus 8? This is taken from the factorization of a cubed minus b cubed, like this. This gives us a minus b into a squared plus ab plus b squared from our mathematics N3. This was our major part that we used. And even in our N4, we need to understand this. There's a factorization that they ask you this, so you need to understand this very, very much. And also, if you are given, maybe it's a positive a cubed plus b cubed, you're going to use a plus b into a squared minus ab plus b squared, like this. All right, so using this, we can see that how can we write this in the form of a cubed minus b cubed? Already here we can see that this is to the exponent of 3. So what we need to ask ourselves is, how can we write 8 as a number that is being raised to the exponent of 3? So 8 can be written as 2 to the exponent of 3. So that means we can rewrite this as x cubed minus 2 to the exponent of 3. If it is written in this way, then it is the same as a cubed minus b cubed. We've got x cubed, we've got 2 cubed in this case. So meaning to say we've got the same manner. So we are going to apply the same thing, a minus b, which is our x minus 2. So that is what you're going to have in this case. All right, so meaning to say this is going to give us limit as x approximates to 2 of this one, like I said, is going to be a minus b, which is our a, yes, x, and minus 2. So we're going to have x minus 2. So we are now factorizing in this case. All right, so that will be x minus 2 in this case. Okay, x minus 2 like this into, this is supposed to give us a squared, which is our a is x. So our a is x, so it's supposed to be x squared. Take note, we are saying this is our x, which is represented by a. This is our b represented by this b here. So if they are saying a squared, this one is this a squared, and this is our a, which is x. So it's supposed to be x squared plus AB. AB, these are the terms. You multiply plus, you multiply these two terms. So it's plus 2 times x. This is x times 2. So x times 2 is same as 2x plus b squared. Our b here is this number 2. So 2 squared is 4. That is 2 squared, which is 4. So this one is going to give us a 4. Everything over our denominator does not change. It's going to remain as it is, which is x minus 2. So this is what you're going to have, whereby we can cancel this time the x minus 2 and the x minus 2. So meaning to say at the end, we are going to remain with the limit as x is approximating to 2 of this remaining expression of x squared plus 2x plus 4 like this. Where now you can substitute the value of x in place of x, we're going to substitute 2, that is 2 squared plus 2 times 2 plus 4 in this case. So we simply say in place of x, we are substituting 2. That is, x is being limited to 2. So at the end, we are going to obtain our answer as 12 in this case. So this is going to give us a 12. So this is how we can answer these typical questions. All you need is to make sure that you are given a question that you can actually factorize. The first thing that you can think of is to factorize. After factorizing, can the expressions can you divide those fractions? If not, then think about dividing each and every term by the term that has got the highest exponent, like what we saw on the previous part here, where we can see that we are limited to a condition that factorization does not even help at all. So what you can do is to divide by the term that has got the highest exponent throughout each and every term. So these are the typical questions that you might have in your syllabus. Let us just have another question to end up everything. So that we can understand this part of our factorization. Let's say we are given, in this case, a limit as x is approaching. Okay, let us just have this as x cubed minus 125, everything over x minus 5. So this is what you're given, and x in this case is approximating to 5. So just like the previous question, you can see that, okay, if you substitute x here being as 5, this is going to give us 0. You substitute that's 5 cubed minus 125. This is going to be 125 minus 125, which is a 0. 5 minus 5, which is a 0 in this case. So meaning to say we can think of our factorization. As you can see, this is a similar question just like the previous part, where we have to apply the factorization of a cubed minus b cubed, where we say this is going to give us a minus b into a squared plus ab plus b squared. So this is what you're going to have in this case. This is x cubed minus 125 written as x cubed minus 125 as a number to the exponent of 3. That is 5 to the exponent of 3. So meaning to say we have got our a represented by x. We've got our b here represented by 5. So we can apply the same concept. So this is going to give us the limit x approximating to 5 of, so we saw that this is going to give us a minus b, which is x minus 5, a minus b, these terms. So we are going to have x minus 5 into a squared, which is x squared. So this is going to be x squared plus ab. That is, you're simply multiplying these two terms. That is your ab, 5 times x, which is 5x, plus b squared, which is 5 squared, which is 25. 5 squared, that is 5 times 5, which is going to give us a 25. All right, so this is what you're going to have at the end, and we are given x as minus 5 in the denominator. So as you can see, just like the previous part, we can cancel the x minus 5 with the x minus 5, remaining with x squared plus 5x plus 25. So this is the limit that you're going to apply at the end if x is approximating to 5 into x squared plus 5x plus 25 in this case. So what it simply means, in place of x, you're going to substitute 5. You're going to substitute 5. That is every part that has got x. So this will be 5 squared plus 5 times 5 plus 25 in this case. All right, so that is our whole situation that you're going to have at the end. And with your calculator, You can simplify everything, and this is going to give us a 75. All right, so these are limits, guys. These are limits. The introduction that we have in our derivatives, that is the limits part, okay, that you just need to understand, so that even if you're applying the first principles, okay, differentiating from the first principles together with the application of the binomial expansion, we shall talk about that in another class. But for now, let us just revise on this part, work on it, more questions, revise from your question papers. That can actually help a lot. But as you can see, it's all about the issue of factorization and dividing by the highest exponent. This is what you just need in your syllabus. We shall have more questions on limits in mathematics N5 there. That is where we shall talk about the L hospitals rule. But for now, that's it, guys. From Maison African Motives, till we meet again.